Okay, guys, so this is F7, and this is going to be something called implicit differentiation. So it's a way of finding a derivative, and I guess I'll just do it. I won't describe it. I'll just do it, and you'll see what I'm about to do is called implicit differentiation. So we're going to find the indicated derivative. So this is number 2 from your practice. They're indicating that they want us to find dx dt. Here I put the steps for how we're going to do that. But before that, I just want to say a couple things. Okay, this is Leibniz notation for a derivative. This is prime notation. These are the same thing. So if you look here, so dy dx in prime notation is y prime of x. It's important to know that the top variable in Leibniz notation, the top variable, which in this case is y, so y is the output, the bottom variable, which is x, is the input. And the output is always a function of the input. So if they're asking you to find dy dx, they're implying that y is a function of x. Okay, so y of x would be the function, and then in prime notation, so y prime of x. So let me just show you a couple more. So dp dq, all right, that's Leibniz notation for this derivative, the derivative of p with respect to q, and in prime notation, it's this. Okay, so p prime of q. dr dt, r prime of t, dx dy, x prime of y. Okay, so if we're going to find dx dt here, we're going to do these steps. We're going to first identify the input and output. Then we're going to convert to function notation where appropriate. Then we're going to find the derivative of each term. Then we will rewrite the function we'll rewrite the equation without function notation. So step 4 is when you do the reverse of what you did for step 2. And then we're going to solve for the derivative. Okay, so first step is identify the input and output. So that's what I kind of already did over here. So if they're asking you to find dx dt, dx dt in prime notation is x prime of t. So guys, what that means, if they're asking you to find this derivative, they are implying to you that x is equal to x of t. Okay, so x is a function of t. All right, so I already identified the input and output. Now I'm going to convert to function notation. So x is equal to x of t. So wherever I had an x before, I'm going to leave a blank. So blank to the third equals 2, blank 1 equals 5t. Not equals, minus. Okay, now in these blanks, there used to be an x. I'm going to put in there instead an x of t. This is important to do because we're going to need to use chain rule to find the derivatives of those terms. So the whole reason we do this step 2 is so that we can see very clearly where we're going to use chain rule and where we're not. All right. So now step 3 is we do the derivative of each term. All right. So the derivative of negative t is negative 1. Okay. T is the input variable, so you just take it like a regular derivative. Minus, I'll bring down the minus, x of t to the third. Guys, this is an in and out situation. The input is a function itself, and then we've got this outer function, blank to the third. So let me do some asides. So x of t, blank to the third. So x prime of t, 3 blank squared, x of t goes back in. All right, so the derivative of this term here is 3 x prime of t, x of t. Okay, so we needed to use chain rule on that. This one, we've also got to use chain rule. So in, out. So x of t is the inside function, 2 blank squared. X prime of t. Oh, darn it, I'm using up space that I'm probably going to want for later. Okay, so the derivative of this is 4 x prime of t x of t, oh darn it, squared. This one was squared. Whoopsie. All right, so I just corrected that, sorry. Okay, now the derivative of this term. This is a constant term. Derivatives of constants are 0. Okay, so that derivative is 0. And then this, t is the input variable, so it's just like a regular derivative. So this is minus 15t squared. Okay. So we did step 3, the derivative. Step 4, rewrite without function notation. So we're going to get rid of the of t parts. So this, we could just go minus 1 minus 3x prime x squared equals 4x prime x minus 15 t squared, okay? I just converted out of function notation because I'm done with chain rule. I don't have to use chain rule for any derivatives anymore. I'm done taking derivatives. Okay, step 4, solve for the derivative. So guys, this, we've got, all right, so this term involves an x prime. So we're solving for x prime. Both of these terms involve x prime. And then these terms do not. You want to get the x prime terms on the left side, the non-x prime terms on the right side, and then, let me just go like this to section, let me just section this off. And then you're going to factor out an x prime and you're going to solve like that way. So I'm going to subtract this term from both sides to get it over there. And then I'm going to add this term to both sides to get it over there. So this ends up being negative 3x prime x squared minus 4x prime x equals negative 15t squared plus 1. Okay. Next step. Since these are both x prime terms, you could factor out an x prime. All right, so in this next step, I'm going to take out an x prime. Negative 3x squared minus 4x equals negative 15t squared plus 1. Okay, so we're solving for x prime, because x prime is the same as dx dt. And then I'm going to divide both sides by the parentheses. So we get that x prime equals negative 15t squared plus 1 over negative squared minus 4x. All right. And you don't have to, guys, but I'll just convert back to Leibniz notation. Okay. This is going to go so fast once we get used to it. All right, let's do another one. So this is number 14. All right, so we've got dw dx. The first step is to identify the input and the output. Well, dw dx, that means y prime of x. So it's got to be the case that, that when we see a w, that really means w of x. All right, so right here I've identified that the input variable is x and the output variable is w. Now, so that was step 1. Step 2 is I'm going to use function notation in this equation wherever appropriate. It's going to be appropriate wherever I see a w. So let me start off by using blanks wherever I had a W, okay? And for where the W's were, we're putting W of X. We do this so you could see where you need chain rule and where you don't. So you don't need chain rule for the independent variable. For the independent is the same as input. So you don't need chain rule for the input variable. You do need chain rule for the output variable, which is the W of X. Okay, so chain rule here. Let me go like this. Okay, so the inside function is W of X. Actually, let me just do these asides. You don't have to do these asides, but I'm going to do it in case it helps. So W of X, -3 blank squared. W prime of X, -6 blank to the first. You know, and then that goes back in. So this is -6 W prime of X, W of X, minus. Guys, we don't really need to do like an inside, it's not focusing. We don't really need to do like an in and out chart here because you're just taking the derivative of W of X. So that's just W prime of X. Here's a regular derivative, 10x equals. Here we need chain rule again. So W of X is inside, -3 blank to the third, W prime of X, -9 blank squared, and then that goes back in. So this is, if you can see, this is -9 W prime of X, W of X squared. Okay, so we did the derivative. Now we take away the function notation. So the W of X's change back to just regular W's. So this is -6 W prime W minus W prime plus 10x equals -9 W prime W squared. Okay, now I got to get the W prime terms on one side. W prime, W prime, W prime. So those are all W prime terms. And then this is the only term without a W prime. So I'm going to subtract the 10x from both sides to get it over here, and I'm going to add this to both sides to get it over there. So this is, so I end up with -6 W prime W minus W prime plus 9 W squared equals -10x. Then I'm going to factor out a W prime. -6W minus 1 plus 9W squared. And then very last step, you divide both sides by this. And I'll convert back right now to Leibniz notation. So there's a lot of like converting notations involved here. Okay, guys. All right, the other videos will be super short.